Hello everyone, this is BB Hirement. Today I am going to discuss the next part of the semiconductor, that is P-type semiconductor. See, P-type semiconductors are the semiconductors which are formed by adding of trivalent impurities. Trivalent impurity means three valence electron. The trivalent impurity is going to add to the intrinsic semiconductor. That improved form of the intrinsic semiconductor only we can call it as an extrinsic, in which if we added a trivalent impurity, and this is we can call it as P type of semiconductor. See, so how that P type semiconductor exactly, that is explained here. So initially this is a intrinsic semiconductor. Intrinsic semiconductor is already told that it is a pure type of semiconductor, there is no dopant. For example, if you consider the germanium atoms, then each atoms inside the material is germanium only. But now you are going to increase its conductivity by the adding process, by the doping process. Then that addition of impurity is a doping. Now you are going to dope trivalent impurity. The trivalent impurities, example, aluminium, gallium, indium. These are the examples of the trivalent impurities. Then pentavalent impurities, examples of phosphorus, arsenic, like that. So now I am going to add a trivalent impurity, that is, you can take aluminium. Aluminium is a trivalent impurity. So out of germanium atoms, I am going to add aluminium. See, aluminium is a trivalent impurity which having a three valence electrons. One is here, another one is here, third one is here. And these two electrons, due to sharing, which forms covalent bond, here sharing of electron, that forms covalent bond. One more covalent bond is formed here, but here there is no valence electron. There is no valence electron. Here only one valence electron is here due to this atom. But so because of only one electron, here there is a covalent bond is not formed. There is no covalent bond is between these two atoms. One free electron is available with one hole. See, one hole is available here. Like that, so 1 in 10 to the power 6 atoms. 1 in 10 to the power 6 atoms, the pentavalent impurities are added. Because of the addition of those pentavalent impurities, here holes are the majority charge carriers. The many m number of holes are created inside the intrinsic semiconductor. Then this is the holes are the majority charge carriers in the P-type semiconductor. Remember it. In the P-type semiconductors, holes are the majority charge carriers and electrons are the minority charge carriers. Then this hole is electrically it is a positive charge. So it's a positive charge, hence we can call it as it is a positive P type of semiconductor. Here the electrons, instead of electrons, holes are movement takes place. In the conduction process in semiconductor, both electron as well as holes, which are reason for the conduction in the semiconductors. Now hole is going to transfer, that is going to excite it from valence band to conduction band. Once that get the energy, a minimum energy is required, that is enough to excite from its valence band to conduction band. Then conduction process starts in the P-type semiconductor. See, like here this is a valence band and this is you can consider as a conduction band. There are so many free electrons instead of free electrons here holes are available. These holes are get energy then excited to the conduction band, that is the conduction process. Okay, this is about the p-type semiconductor. Then the next concept is about, the next thing is PN junction. See here, PN junction that consists of p-type semiconductor at one side of the single crystal and N-type semiconductor at the another side of the crystal. Then the combination of these two types, the p-type semiconductor and N-type semiconductor in the one single crystal. So this is what we can call it as PN junction diode. Here the manufacture of this PN junction or formation of PN junction is like this. At the molten state of germanium or silicon, one trivalent impurity and pentavalent impurity which are added into the single crystal of germanium or silicon at the molten state. Then the p-type is one side and n-type is another side in the single crystal, and this is what we can call it as PN junction or a PN junction diode. Junction diode. Then here, so what happens here? The majority charge carriers in the p-type of semiconductor is holes, and minority charge carriers in the p-type semiconductor is electron. And in the n side of the semiconductor, the majority charge carriers are electrons and minority charge carriers are holes. What happens here? Due to carrier concentration of the charges, the electrons are diffuses into the p side of the crystal, and the majority charge carriers in the p-type which are diffuses into n-type of semiconductor. Due to diffusion process, there is a layers formation at the junction. The n-type of semiconductor layer, the layer of electrons, the layer of n-type which is formed on the p-type semiconductor. See here, totally this is the p-type semiconductor. On the p-type semiconductor there is an electron layer is formed, and on the n-type semiconductor here whole layer is formed due to diffusion process. And so because of these two layers, the electric field is formed between these two layers. As a battery is connected to a 50 battery is connected to p-type and n-type, like this. See, if we connected our battery to the p-type and n-type, see, the positive terminal to the negative side, n-type of semiconductor, and the negative side of the battery is connected to p-type semiconductor. Like this, here, this depletion region which forms the electric field between these two layers. Due to electric field, what happens here? Electrons are drifted. The electrons are drifted towards the p side, and holes are drifted towards the n side. That's why here drifting current is developed due to these two layers. Due to these two layers, p-type and n-type, here electric field is developed. Due to electric field, what happens here? The electrons and holes are drifted. Then drift current is generated. Initially, a diffusion current is more. As diffusion takes place, the layer becomes increases because of the diffusion. See, holes are diffuses into this side and electrons are diffuses into this side. And these two layers, the charge concentration, the carrier concentration becomes increases at the layer. See here already there are 4 holes are example. There are some example here. The 4 holes are present. Because of the ion diffusion, the number of holes increases. As number of holes increases like that, here electrons also increases at the layer. Then nothing but the charges at the layer, the concentration of the charges at the layer that is increases. As charge concentration increases, the layer becomes wider. That is also increases in the size. As the size increases, the electric field is also increases. As electric field increases, then drift current increases. This process will continue till diffusion current and drifting current becomes equal. Once these two currents are equal, then this is now current, net current of the in the junction is equal to 0. Then, so this junction we can call it as, so here depletion takes place and this junction we can call it as depletion region. See here, the junction between P type and N type, this is what we can call it as PN junction. Because of the depletion here, this is also called as depletion region. Depletion region. Then one more thing here, so because of the charges, here the negative charges in this side and positive charge in this side, the potential is developed. The potential is developed. Due to the potential difference between these two, the charges moving from this side and this side is opposites. See here, we know the basic concept in the potential. These two charges. This is the one side of the layer. It is actually like a negative potential. Another side is actually like a positive potential. Then there is a potential difference is developed at this region. This is what we can call it as potential barrier. This is acts like a well. This is acts like a hill. This is acts like a barrier wall. So that's why. So this electric field, this potential difference, which opposes the motion of the charges, like positive charge or negative charge. So which does not allow to flow these charges, that opposes the motion of the charges. That's why this potential we can call it potential difference, we can call it as potential barrier, potential wall, potential hill, like that. So this is about the PN junctions. Here PN junction, define PN junction. That is a junction between P type and N type of semiconductor. We can call it as PN junction. This is a concept of PN junction. Thank you.